Hi, everybody. This is our Team Teach Chapter 10, Length, Area, and Volume. My name is Amanda Pennington.
Callie Plummer.
Joni Overly.
Gabrielle Guest.
Diane McDormand.
And Jerry Bowling.
And we are going to be talking about different shapes and figures and different hints to help us solve these in mathematical ways. So we're going to go ahead and get started. Callie, what is the easiest way to find out how many mouthfuls are in a cup?
Well, since the measurement system is also a doubling system, the easiest way to set all of your measurements on an equal playing field is to set them to their base measurement, which in this case would be mouthfuls because it is the smallest unit of measurement. So set them to the smallest would be the easiest way to find out how many mouthfuls are in a cup.
Well, thank you. I appreciate that.
Gabby, will you answer this for me?
Yes.
How many mouthfuls equal 3 Jills?
Okay, so first you want to know how many mouthfuls equals 1 Jill, and that would be 8. So if you have 8 mouthfuls that equals 1 Jill, and you want to find out 3, so you just multiply 8 by 3, and you get 24 mouthfuls that are equivalent to 3 Jills.
All righty.
Joni, on question 1, how many mouthfuls are in a quart?
Okay, so and this is a part of in this question. This is a part of a doubling system. So to get a quart, we have to double 2 mouthfuls 5 times. So you're going to say 2 times 2 is 4, and then you're going to say times 2 is 8, times 2 is 16, times 2 is 32. So 5 times that was 32, so it is going to be 32 mouthfuls.
Thank you.
Gabby.
I have a question for you. How many pints would equal 96 mouthfuls?
Okay, so the first thing you need to know is how many mouthfuls equals 1 pint. Okay, so these little smiley faces represent a mouthful, and all you got to do is just count up all of the little smiley faces, and it comes up to be 32. So if you have 96, we know that 32 times 3 would give you 96. So it would be equivalent to 3 pints versus 96 mouthfuls.
Good job explaining. Thank you.
Thank you. Cheyenne, how many mouthfuls does it take to fill 2 jacks?
Well, if we know that 1 jigger equals 2 mouthfuls and it takes 2 jiggers to fill a jack, then we need to double how many mouthfuls to fill that jack. So it'll equal 4 mouthfuls.
Okay, thank you.
Oh, Gabby, what 2 things can make up a jagger equally in the same amount?
Okay, so on the original example, we were given a pail to fill it up with all these different values and stuff. So we look at this jagger right here next to the mouthful, and we know that a mouthful would be half of what a jagger would be. So all you would have to do is know that 2 mouthfuls would equal 1 jagger. So those are the 2 things that can make up a jagger equally.
Thank you so much.
Jerry, for question 2A, can you find the perimeter of the triangle?
Yes, I can. You use the simple equation of side plus side plus side, which in this question you use 48 meters plus 69 meters plus 82.3 meters, which equals 99.3 meters. And that is the perimeter of this triangle.
Great, thanks so much.
Callie, question 2, part A. How is the perimeter different than the area of the triangle?
Well, the perimeter of a triangle is simply just the outside measurements added together. And the area of a triangle is all the space inside the perimeter of a triangle.
Good job, Callie.
Thank you.
Okay, Gabby, explain in depth how to find the perimeter in this figure and why do you not include the 41.0 meters?
Okay, so perimeter is pretty simple to figure out on a shape. All you need to know is that the perimeter is the outside of a figure, and to find it, you have to add up all of your values. So you do 82.3 meters plus 48 meters plus 69 meters, and you get 199.3 meters. And the reason that you do not add the 41 is because that just represents the height of the shape, and that's on the inside, which is not perimeter.
Okay, great, thank you.
Amanda, how would you find the area of a triangle and the perimeter?
Alrighty, so with this question, we're going to look at this triangle, and we have all the measurements for these sides. We know that the area of a triangle is going to be the equation of 1/2 base times height. So we know automatically that we're going to have to use the base and the height. So the base is going to be 37.0 inches, and then the height is going to be 88.8 inches. And when we plug that into our equation, we're going to get the answer of 1,642.8 inches. And then for the perimeter, like you said before, we're going to take the outside measurements of this triangle, and we're going to add those together, which is going to be side A, side B, and side C. And when we add all those together, we get 222 inches, which is the perimeter.
Good job.
Great, thank you.
Thank you. Harry, how would you find the area of this triangle?
That's a very good question. You use a simple equation, 1/2 base times height. My base is 88.8 inches, which is that side right there. And then our height is 37 inches tall, which that equals 1,642.8 inches square. And
Great job.
The area.
Cheyenne, what is the perimeter and area of this figure?
Well, to find the area or the perimeter of this triangle, we need to add up all the sides. So you add up 15, 25.3, and 45.2, which will give you 85.5 meters. To find the area, we need to use the formula 1/2 times base times height. So we're going to take 1/2 times 25.3 times 15, which will give you 189.75 meters square.
All right, Gabriella, go into depth on how you find the area of this figure and how to fix common mistakes through the process.
Okay, so area is also pretty simple. You just have to plug in your formula and your numbers into it. So the formula to find area of this figure would be 1/2 base times height. So we know that we have to take 1/2 and of 88.8 inches, which is the base, and then you have to multiply it by the height, which is 37 inches. And then you get the answer of 1,642.8 inches squared. And to find and fix common mistakes, you just have to remember to take 1/2 because sometimes people forget.
Thank you. That was a good answer.
Joni, how do you find the area of a triangle?
Okay, so pretty simple. We've gone over this before. Our area of a triangle is simply going to be a formula that we very well know is area equals 1/2 times base times height. So in this problem right here, you are going to plug in your numbers here, your 88.8 and your 37, and you're going to multiply all those together. Your 1/2 times 88.8 times 37, which equals 1,642.8 inches squared. And that's it.
Well, thank you. I understand now.
Amanda, what do you use for the height value instead of the side value in a triangle?
That's a good question. So in this figure, we see already that this triangle looks very particular because we see the length of this side, the 3.1 centimeters, and then we see this big line that says 2.6 centimeters. And that line is going to say that that's the height. And the 3.1 is going to be the length of that side of the triangle. So for the area of a triangle, you have to use the height portion, the 2.6, to figure out the area. But in the parameter, you are going to use the side, the 3.1 centimeters in the equation, and not the height, because you want the area of that specific triangle. And so that's how you can tell the difference of when to use the height value and when to use the side value.
I understand that now. Thank you.
You're welcome.
Jerry, in question 2, part C, how do you solve for the perimeter of this triangle?
That's a very good question. Well, you take each side of the triangle, not including the 2.6, which that's not a side, and you get your answer, which is 6.2 centimeters plus 3.1 centimeters plus 8.5 centimeters equals 17.8 centimeters. Does that solve your question?
Yes, it does. Thank you.
Thank you.
Okay, Callie. Homework question number 3. How do we find the area of this smaller circle with a given diameter of 10?
Well, the area of the smaller circle is equal to pi r squared. And so we know that the radius is half of the diameter. So we plug in 5 for r. And you just follow the equation and you get 25 pi units squared because area is squared.
All right, thank you.
Joni, how do you find the area of our circle?
Well, we just kind of talked about that. That's just very simple. We're just going to use our formula pi r squared, and we are going to plug in our numbers to that. And that's it.
All right, thank you.
And I'm sorry, our pi is 3.14, so that's what we would be multiplying.
I did not know that. Thank you so much. I appreciate it.
You. All right, Jerry. How do you find the radius and the area of this figure?
Well, you start out with the radius, and you take the length, which is 20 units, and divide it by 2, which is 10 units. And then to get the area, you take 10 units times pi, or the 10 units squared times pi, which you get 100 units times pi squared. Does that solve your question?
Yes, thank you.
Amanda, how do you solve for the ratio of each volume object?
Okay, so to solve for the ratio of each volume object, we are going to look at a cylinder. And in that cylinder, there's going to be a pyramid. And in there also is going to be a sphere. Now we're going to look at the volumes. So we have to divide it by the volume of the cone. And so for the pyramid, so you're taking the volume of the cone, and you're taking that equation, the 2/3 pi r to the third power, and dividing it by itself. And we know in math that anything divided by itself is always going to give you a 1. So that's volume of the cone is going to be a 1 ratio. Now, when we look at the volume of a sphere, that volume is going to be 4/3 pi r squared for the sphere itself. But we're going to divide it by the volume of the cone, and that's going to give us a 2. And now the cylinder, so the cylinder is going to be 2 pi r to the third power. And so, again, we're going to divide it by the volume of the cone, and that is going to give us a ratio of 3. So the ratio is going to be 1 to 2 to 3 for the volume of the cone, the volume of the sphere, and the volume of the cylinder.
Okay, thanks. That was a great explanation.
Thank you.
Joni, how do you find the volume of a pyramid?
So we will just use our formula that we know. It's going to be your 1/3 times base times height. And you just plug those numbers in, and there you go.
Thank you. That really clears things up for me.
All right.
Just 1 second, and we're going to the next slide.
Cheyenne, what is the surface area and the volume of a sphere?
Well, to find the surface area of the sphere, we need to use the formula. Where's my formula? 4 pi times r squared. So if we know that the radius is 10, we need to plug that into our formula. So it'll be 4 times pi times 10 squared, which will give us 1,256 inches squared. To find the volume of the sphere, we need to use the 4/3 times pi times r cubed. So we're going to plug our numbers in. So it's going to be 4/3 times pi times 10 cubed, which will give us 4,188.79 inches cubed.
Good job.
Thank you.
You're welcome.
All right, Callie, I have a question for you. On homework question number 4, part B, how would you divide the volume of a cone by the volume of a cone?
Well, when dividing anything by itself, the answer will always be 1, and this rings true for the volume of a cone. So 2/3 pi r cubed divided by 2/3 pi r cubed is 1.
Thank you. That clears things up.
Mm-hmm.
Cheyenne, how do you find the area of this figure?
Well, we need to look at this figure as 2 different things. So first we're going to look for the area of the rectangle. So you're going to use the formula length times width. So our length is 56.3 and our width is 20.3. So that will give you 1,142.89 feet square. Then we need to find the area of the triangle. So we're going to use our 1/2 times base times height, which will give you 439.14 feet square. And then we need to add those areas together, which will give you 1,582.03 feet square.
Thank you so much. I like how you took those apart for me.
You're welcome.
Amanda, how would you solve for the surface area of the right trapezoidal prism?
Okay, so just kind of like what Cheyenne did in the previous slide, we are going to break our shape down. So we're going to do a rectangle and a triangle. And so doing that, you will see on this slide, the looking straight down at the figure, the shapes, and that kind of helps me understand how we're breaking that down into a triangle and a rectangle. And then you will solve for the area of the rectangle, the area of the triangle, and then you will add those together. So as you can see, the area of the rectangle is in the gold, and the area of the triangle is in the blue. And the new base is going to be the 258. And we know since the figure is 3D, we're going to add 2 bases to that, and then the height of the shape, which is going to be the 280. And the surface area altogether is going to be 796 centimeter square unit. And that will be your answer.
Well, thank you for breaking that down.
You're welcome.
Joni, what is the formula for finding the surface area of a right trapezoidal prism?
Okay, so the surface area is going to be your formula, your 2 times base plus the perimeter times the height. So in this one, you can just plug those numbers in right there, and you'll have your answer of 258.
Thank you. That clears things up for me.
Jerry, how would you find the surface area of this figure?
Use a simple formula. Find the area, surface area formula, which is SA equals 2B plus PH. How you get the base is you take 1/2 plus AB, which AB is 26 centimeters plus 17 centimeters, and times 12, which is the height, equals 285 centimeters square. And then you get the P, you take 26 centimeters plus 15 centimeters plus 17 centimeters plus 12 centimeters, you get 70 centimeters. And then you finally fill in all those answers into the equation, which is surface area equals 2 times 258 centimeters plus 70 centimeters times 4 centimeters for the height, which equals 796 centimeters squared.
Okay, thank you.
Was that a little too complicated?
It was good.
Okay, Cheyenne, what is the surface area of a cube?
Well, to find the surface area of this cube, we need to use this formula of SA equals 6 times A squared. So we know A equals 16. So we're going to take 6 times 16 squared, which will give you 1,536 centimeters square.
Thank you so much. That helped me.
You're welcome.
Callie, question number 5, part A. When using the formula SA equals 2B plus PH to find the surface area of a right trapezoidal prism, how do we find the inputs for B and H?
Well, B stands for base. And so to find base, you use the formula 1/2 A plus B times height. And so when you plug in the correct numbers here, it would be 1/2 17 plus 26 times 12, which is 258. And then to plug that in for surface area, and then you have to find your height. And in this case, the height is 4. So you make sure not to get this confused with the measurement of the longest side of the triangle, because that's not correct.
Well, thank you for breaking this up for me. I really learned something. Thank you.
Oh, good.
All right, Gabby, what does a perimeter truly mean, and how do you find the perimeter in a shape?
Okay, so basically perimeter is the outside of a figure. It's like the border of something, and it's pretty simple to find a perimeter in any shape. You just have to add up all of your side lengths, which are stated in this figure right here. So let's look at right here. P equals, and you'd add one side length, which is 26 centimeters, plus 12, plus 17, plus 15, and it would equal 70 centimeters. It's just that simple.
Oh, thank you.
Jerry, can you find the surface area of the figure?
Yes, I can. To find the area, we start off with 1/2 base times height for one of the triangles, which is A equals 1/2 base times height, which is 15 meters times 7 meters equals 52.5 meters. And you get the perimeter, which is P. You add up all the sides together, which is 40 meters. And then you take the equation, which is SA equals 2B plus H, which equals 2 times 52.5 plus 40 times 7, which equals 385 meters square. Does that solve your question?
Yeah, it did.
Good job. Hey, Amanda, why would you use the formulas for sphere and a cylinder to solve for the surface and volume?
That is a good question. The reason why you use the surface area equation for a sphere and a cylinder is because in this figure, we have a cylinder in the middle, and then on the end, you can see half of a sphere. And so since it's on both ends, that is a whole sphere for you. And so you need to add your equations for both of those into the shape when you solve, because you're not doing one shape, but you're doing two shapes together.
All right, thank you.
You're welcome.
Callie, I have a question about homework question number 6. When finding the surface area of figure with the formula SA equals 2 pi r plus h plus 4 pi r squared, how do we find the inputs for r and h?
Well, R is the easiest input to find because we're given the diameter, and so we know that we need to take half, which is 4, and H is, in this case, is going to be the length of the cylinder, which is also a given number of 21.
Thank you. That was great.
Okay, Joni, how do you find the surface area of a sphere?
Okay, so your surface area, you are going to just use your formula, the 4 pi, which is 3.14 r squared.
Thank you.
That is it.
Great job.
Ooh, guys, we're running low on time.
Cheyenne, what is the volume of a cone, and can you find the area of the base?
Well, to find the volume of a cone, we need to use the formula 1/3 times base times height. But first we need to find the area of the base. To find the area of the base, we need to look at the base as a circle. So we're going to use the formula pi r squared. So to plug in our numbers, we're going to do pi times 10 squared, which will give you 314 inches squared. Now we're going to plug in, or not plug in. Now we're going to find the volume. We're going to do 1/3 times 20 times 15. Since 15 is our height, that'll give you 100 inches cubed.
Okay, thank you.
You're welcome.
Hey, Amanda, why is it important to know what the height of the cone is?
That's a good question. So when you want to find the surface area of any cone shape that's involved, you need to know what the height 2 is. And the height 2 is going to be given because we have this cylinder height, which is going to be our height 1 for the volume, which is seen right here in this equation. And so you're going to use that in the equation, like before we discussed that if you have two shapes, you have to use both equations for each shape. So we have this cylinder height, which is this portion. But for the height 2, we need to find the height of the cone. And without the height of the cone, you can't even solve for the volume or solve your answer. And so that's why it's very important to make sure you have all those height measurements.
All right, thank you. Okay, guys, thank you all for coming and listening to our lesson today. This concludes it for this week, and thank you so much for listening. Bye, y'all.
Bye.
Bye.